This is our just-in-time lecture over Section 7.7, Dalton's Law of Partial Pressures. By far, the most often missed question was the very first one. I was hoping that when you guys added the partial pressures together, you would recognize you needed to keep 3 significant figures, which would mean that to make sure that was unambiguous, you'd have to add this decimal place. So there were 2 answers there. They were identical. The correct answer was 770 with that decimal place. However, given the high number of students that chose C, I did go back and regrade this, and everyone that chose C or D got full credit. All right. In the future, please pay attention to significant figures. This question had E and C, so E and C as the most common wrong answers. The question asked, what is V? So this was just making sure we can match up quantities with their units, with their variables. And here, looking at the units, the only one that has a unit that matches volume is liters. I can't stress to you guys how important it is to look at your units. If liters is the only option there, then this should be an easy point. Kelvin is temperature, and all the ATM that relates to pressure. This question says that given we have values for P, V, and T, and we need to solve for N, which gas law is needed? All right, I listed the ideal gas law right there on the slide, and the most common wrong answer was the combined gas law, but this one does not have N, so this one is missing the moles. So the ideal gas law is the key one there. On this question, I was asking you to complete the calculation I had written out here, solving for moles of O2. Now, we'd already done this one way and gotten 0.273 as the correct answer. And I was showing a second way to do this, and so the answer is still going to be 0.273 moles. I did get C as a common wrong answer, and some people went to N total, but this was definitely the best answer. So watch the slides, watch what I'm doing on the slides. This one was just a plug and chug. So finish this calculation, choose the right answer. This question was asking about the amount of water vapor that shows up in a gas sample. So we're talking about how much water vapor shows up here. And we see from a graph that this is temperature dependent, a fact that I reiterated down here in the transcript. It's dependent upon the temperature of the mixture. It is independent of the volume or of the liquid or the gas mixture. So temperature was the best answer there. This question was asking you to read the question and then report back P total. So A was the correct answer, although I did see some B, which is the partial pressure of water, and I did see E, which is P total plus the partial pressure of water. That's not how we work these problems. P total is equal to the pressure of H2O plus the pressure of O2 in this case. All right, this is our last most often missed question from this particular PlayPosit lecture. I was asking you to give me the final answer, the partial pressure of O2, and I had it set up down here all nice and pretty for you. Partial pressure of O2 is equal to the total pressure minus the partial pressure of H2O. My most common wrong answer was B, by far. This is the partial pressure of H2O. My other common wrong answer was D. And if we consider this is P total, and this is the right answer right here, all right, D means that we're taking P total and adding to that the partial pressure of H2O. Remember, P total is the sum of all the partial pressures. So you should never get a number bigger than P total. And since P total was 759 here, anytime you see this on an exam or a quiz, just go ahead and cross that out. We can't get higher than the total pressure. If after watching this just-in-time video you still have questions, keep in mind I have office hours on Tuesdays and Thursdays from 2 to 3:15. Just go to Canvas and click the Zoom link. And I'm also happy to answer these questions on Piazza anytime.